Welcome back to our second video on Class Notes 2-3, Introduction of Mixtures, is what this particular set of notes are focusing on. In our first video, we had a review of the difference between mixtures and pure substances, and then we introduced a type of mixture that is categorized as homogeneous or homogeneous, and those mixtures are the same throughout. The second video on Class Notes 2-3 is focusing on the other branch of mixtures, which is called heterogeneous or heterogeneous mixtures, and these are ones that are not the same throughout. So homogeneous, you cannot recognize parts within the mixture. Heterogeneous mixtures, there are parts within the mixture. They are not the same throughout. Some examples of heterogeneous mixtures are mechanical mixtures, suspensions, colloids. We'll also mention emulsions. And as we move down in our notes, we are picking up right here heterogeneous mixtures. These are mixtures that are not uniform in composition. They are not the same throughout. You can see different parts within the mixture. The one that this is most obvious with is mechanical. Mechanical mixtures, the different parts are clearly visible to the human eye, and they are distinguishable. With some of the other ones, they are different parts in there. You may have trouble seeing the different parts with your eyes, but there's ways you can tell whether a mixture is homogeneous or heterogeneous or heterogeneous by certain tests that we'll talk about. But mechanical is very easy to identify in terms of it being not the same throughout, because in this one you can clearly see the parts to the mixture, such as soil. If you take a shovel full of soil, you can see there are different parts in that soil. It is not the same throughout. If you go to the beach and you take a scoop of ocean water and you go straight down and grab some of the sand out of there at the bottom, so you have sand in with the water, you can definitely see the different parts from mechanical. Another type of heterogeneous mixture is called a suspension. A suspension is a little bit different than a mechanical mixture. Mechanical mixture, the different parts are clearly visible. With a suspension, it is a cloudy mixture where tiny particles of one part of it are held by the other part of it. So when it starts out, a suspension, you have one part of it suspended within the other part of it. That's why you call it a suspension. One part of the mixture is suspended or held by the other part. But over time, they will settle out. So over time, part of the suspension, the part that's held there, will settle out, and you would have to shake it. So the way to get it to mix back up. So the way you can recognize a suspension is you have to shake it. Right after shaking it, the one part is suspended by the other part, but over time they settle out. So what's the difference between a mechanical mixture and a suspension? The mechanical mixture, they settle out very, very quickly. The soil will go to in soil, there's parts that'll be mixed within the other part. In sand definitely settles out of the water right out of the gate. A suspension, you might have to wait for a while for them to settle out, and you must mix it. A third type of heterogeneous mixture is called a colloid. A colloid is different than a suspension in that the suspended particles are so small that gravity will not separate them. So the difference between a suspension and a colloid is over time the suspension settles. A mechanical, it settles right away. A suspension, over time it settles. A colloid, it will generally not settle at all. Gravity will not separate it. Some examples of colloids are whipped cream, mayonnaise, fog, mist, smoke. These are different examples of colloids. Colloids can be classified several ways as well. There are different types of colloids. One type of colloid, Sol, and that really stands for a solid, tiny little solid particles suspended within a liquid. Solid within a liquid, Sol. Emulsion is a type of colloid between two liquids. So solid in a liquid is a sol. Two liquids is an emulsion. An emulsion, and we'll be talking more about an emulsion in a bit, but they are not miscible. They do not stay mixed together. A foam is when you have many gas particles trapped within a solid or liquid. So foam has gas trapped within a solid or liquid. A gas has particles of a liquid or solid within the gas. So foam is lots of gas in a solid or liquid, and aerosol is liquids or solids within the gas. So those are some types or different types of colloids. Now, the ones a lot of students get confused are whether something is a suspension or whether it is a colloid. Now, suspensions, as we mentioned, are easy to tell the difference between a suspension and a mechanical mixture, because mechanical mixture clearly separate immediately. So what does a suspension? Well, it is a heterogeneous mixture, and its particles are larger than 1,000 nanometers. So what's the difference between a suspension and a colloid? The diameter of dispersed particles in a colloid is smaller than 1,000 nanometers. So colloids are made up of smaller particles than suspensions. That's one difference. A second difference, a suspension, the particles will separate on their own. Gravity will pull them apart after a somewhat short time, and you'll need to shake them, as we said. With a colloid, they will not separate over time. They will not precipitate out, and you don't need to shake a colloid. Another difference, suspended particles you can see by your own eye. You can actually see them. Whereas with a colloid, the particles are very, very small. You would need an electron microscope to see them. They are so small. And another distinction between a suspension and a colloid is with a suspension, you can separate them by a process called filtration. You can pour it through filter paper and trap the particles in the suspension. For a colloid, they can go right through the filter paper. You can't separate them with filtration. An important aspect of colloids is recognizing the fact that a colloid is essentially a mixture of two phases of matter, two different phases. So like solids with liquids, liquids with solids, solids with gases, gases with solids, liquids with gases, gases with liquids would all be ways you could make a colloid. But for it to be a colloid, we're talking about very, very small particles. Let's take a look at some different ones. Gels, foams, clouds, milk. Those are all examples of colloids. Along the lines here, we see emulsions, which is a liquid in liquid, smoke, foam, milk, aerosols, fog, gels, clouds. But let's take a look at how those different examples of colloids would be categorized, types of colloids. We already mentioned SOL, and we said SOL or sol. One way you can have a sol is a solid in a liquid, and that would involve things such as paints and gels and dyes. An emulsion is a liquid in a liquid, such as mayonnaise, milk, salad dressings, creams. Foam, that is a gas in a liquid. Foam would be a gas dispersed within a medium of a liquid. Beer froth, soap suds, whipped cream. Solid sols. Well, what is a solid sol? That is a solid in a solid. Some alloys could be categorized as a colloid, solid within a solid. Gemstones, rubies, glass, a mixture of a solid within a solid. Solid emulsions. That's another type of an emulsion where you have a liquid within a solid. Butter and cheese. Now, you're not going to need to know all these, but we're just taking a look at them to recognize these. Solid foam. What is a solid foam? That would be when gas is within a solid, such as pumice. If you've seen that stone, pumice. Marshmallows actually have gas dispersed within the solid. And lemon meringue. What is a solid aerosol? That's when you have solid within a gas, such as smoke, dust in the air. Bacteria in the air would be solid within a gas. And then you can have liquid aerosols where liquid is in the gas. So when you see the word gas, aerosols last, that means it's in a gas. Aerosol means gas. Liquid within a gas would be fog, mist, clouds, and spray. So those are some types of colloids, very, very small particles. So small that it's sometimes difficult to recognize a colloid, the difference between a colloid and a solution with your own eyes. So how can we tell a colloid from a solution? Well, colloid particles are suspended, and they are very small, and gravity will not separate them. But they are large enough that they would scatter light. So if you shine a light through a colloid, it will scatter that light. That's called the Tyndall effect. And this is why you do not turn your bright lights on when you are driving in the fog in the morning or at night. So in the fog, you don't turn your lights on because fog is a colloid. And it will scatter that light in all directions into the eyes of oncoming drivers and so forth. You can blind yourself and the other drivers by turning your brights on. You want your low beams on to go underneath the fog. That's unlike solutions. If you shine a light through the solution, the dissolved particles in the solution are so incredibly small that the light passes right through them and it won't be scattered. So an emulsion. What is an emulsion again? It is a type of colloid, specifically one liquid within another liquid. That's the liquid versus liquid. On our list of colloids, and we'll talk a second here about emulsions, but it just made me remember that if you noticed on our list of colloids, there was no gas in gas. So we look on here, we have no gas in gas on that list of types of colloids. And that's because when we have a gas in a gas, it's actually a solution. They're in the same phase and they would mix evenly throughout. It would be homogeneous. There's nothing that will hold the gas particles together. They're free to move wherever they want. They spread out evenly. That's homogeneous, not heterogeneous. Just about every other combination would be heterogeneous. They are in different phases there. They're in different phases. All right, and our final type is an emulsion. As we mentioned, emulsions are a little confusing to understand and how they're different, like what makes an emulsion kind of a unique type of heterogeneous mixture. So as we mentioned, emulsions are when you have two liquids that are immiscible. It's a type of colloid. And emulsions so often involve oil and water. And another type of emulsion is water dispersed within oil. And this is so common in the food industry. And they do not mix. They're found in salad dressings. They're found in mayonnaise. They do not mix very well. Some salad dressings will settle out over time. The oil and water are not, they do not mix. They are immiscible and they will separate and you have to shake them or whatever to get them to mix. But very often they put in something called an emulsifier. So emulsifiers keep the liquid in liquid emulsion stable so it doesn't separate. Here's mayonnaise, what mayonnaise looks like. You've seen mayonnaise, but with an emulsifier, it stays just like that. If mayonnaise didn't have an emulsifier, a thing to keep it stable and together, it would separate into the oil and the water components, and it would look kind of nasty. It's not very appealing. Emulsifiers are very common in food additives. They're used to make the food more appealing. So that's what emulsions are. In our final video, our third video, we'll take a look at ways to separate mixtures. You do not need a chemical reaction. You can separate them physically, and we'll take a look at ways to separate them physically.